Okay, kids, we're back. I've had some real luck with this thing. You'll recall from the previous video that I explained the function of the gyro accelerometer and how it's displayed on the OLED. Incidentally, notice the thinness of the OLED because there's no backlight. And so the next move was to learn to talk to the NRF24. I spent 2.5 days debugging a problem. I hadn't set what's called an EOT bit, and I was getting what's called a stall. I had no idea what either of those were for before this debugging session. So it took me a while, but I've learned now, and now I can communicate readily with the NRF24. Now, one of my design goals was to not put a button on this board. So I'm taking full advantage of the gyroscope. And what I've done here is I've made it so that if I turn it off and put it in a different position, it will come up in a different program. Now this program is a spectrometer that is functioning as a result of the NRF24. Basically, and I'll explain. In fact, I'm going to have to get a little closer to my router so you can see the spectrum. But let's get a little closer to the router. Bingo. Now, what this means is, I'll settle it down here in a second. The left-hand side over here is 2.4 gigahertz. The right-hand side is 5 gigahertz, 2.5 gigahertz. And what you're seeing is there's a receiver in the NRF24, and you can select the channels. There's 125 channels. Each one's a megahertz. So each line represents a megahertz from 2.400 to 2.525 gigahertz. And as you can see, there's quite a bit of activity above 40, channel 40, and not much below it. This came about because I was getting ready to fire up the transmitter in the chip, and I didn't know what channel to use, and I wanted to be legal and everything. So then the natural outcome of that was, well, I'll just try to build a receiver. I noticed that someone made a scanner with this chip, so it's quite simple to do once you start communicating with it. It's scanning all the channels, and it has a receive power bit. Receive power, and so you just change the channel, wait a millisecond, and then check that bit. And if it sees a receive power, I add that to the counter for that particular channel. So it gives you a pretty good idea of where the energy is going. And that was quite unexpected. I didn't expect to go. I wasn't really planning on that. But this whole project has been extremely interesting. I'm really excited. The next phase will be to fire up the transmitter and start sending data back and forth. And let me think if that's about all I wanted to share today. It's pretty exciting. I'm going to definitely look at using lower channels for my little in-house communications, or basically what I'm going to do eventually is mount the accelerometer on a windmill and monitor the wind speed by RF link. Anyway, there's a lot of data for you. Thank you very much for watching, and best of luck to everybody. Bye-bye.